me what is wedge? You know what is wedge? Wooden core block or metal structure. So for supporting or balancing something, let's say this is a table, there is no balance. So then we will put something here to balance it. So that is called wedge. So let's say this is like this kind of structure, or mostly it is trapezoid in shape. So these are all called wedge. Okay, so this is like metal or wooden structure. Wooden structure used to balance any load or related parameters. Okay, so suppose this is our inclined surface. Okay, this is inclined surface, and this is also one inclined surface. Two surfaces actually. This is inclined surface. This is horizontal surface. So we are putting a block here. So it will slide this side, so to stop it sliding, we will put a, let's say, this kind of structure. So this is a wedge, and this is our loading structure. Okay, so in this way, wedge will balance this load to rest its position. So these are the main concept behind a wedge. Now, because of this surface, there will be some friction here also, So we will understand, we will solve this problem for wedge friction. So this, there will be some friction. So in this surface also there will be some friction. Okay, that is called wedge friction. So this is your wedge friction. The same concept is same, but we will see in another way. Throughout the whole engineering mechanics, remember only three equilibrium force: summation of momentum. Yes. Let's say this is your this is given 75 degree. This is your one surface, inclined surface. This is your horizontal surface. Okay. Now this is a, there is one block. So this is empty, nothing is here. Okay, let me draw it like this. This is yours. Another block is here. So this is our supporting block. Now here we have some load P, and here we have 1600 Newton. This way 400 Newton. Question is like that: determine the force P as shown in the figure. To start the yes, please come. How are you? Stomach full. Movement of wedge. The angle between angle of friction actually. Angle of friction between the wall is 15 degree. Okay. Today we are discussing wedge surface. Get settled down. How was the exam? Friction and angle. Friction and angle. Friction and angle, this is 15 degree given. No, that is incline angle, and that is friction angle. What is the difference? This is an incline angle, and that is frictional angle.
That wall and force of friction.
Yes. You know this mu is equal to tan phi. You know na? This phi is given 15 degree. Okay. So for them, I will repeat. Today we are dealing with wedge friction. Okay, wedge friction. Wedge friction. What is the meaning of wedge? So let's say this is your table. It is not balanced. Some portion is cut from here. So you will put some another structure. Let's say metal or wooden structure. That is called wedge. So if a block is sliding like this, and if you put some structure here, so after some time it will come and it will stop. So this is like wedge. Because of that, there will be some friction through its surface. So we will discuss all these things. This is a problem. Determine the force P. This is P load as shown in the figure. To start the movement of wedge, the angle of friction between all the wall is given 15 degree. Actually, we have to calculate this force P, for which this wedge will start to move. Because of this block, it is stopped. We have to calculate this load P. Actually, what is happening? So let's say this is your, how can I say? So let's say this is your surface. If you move it, one structure you put it like that. If you raise this inclined angle between this and this will be increased. So after some time, see, this is not sliding. This is not sliding. Now it is start to slide now, and it is fallen. So that angle you have to calculate. This P. That is called angle, threshold angle. So after that angle, this body will slide. So that point, that load we have to calculate actually. So we'll calculate now. Same concept. How many force equilibrium condition we have? 3. Summation of is equal to 0. F of x is equal to 0 and
Momentum.
so these are all 3 available equilibrium conditions. So for solving this problem, the first is we have to draw its free body diagram. Right. Free body diagram. So first we will consider this block, then we will consider this block. We have 2 blocks now. So first draw the free body diagram of this block. So this is very important. In engineering mechanics, free body diagram and available 3 equilibrium conditions. If you understood it well, any problem we can solve. Draw free body diagram. First, draw the free body diagram of this. So this should be like, we'll remove its surface. So remove. This is like 75 degree. Okay, and this is the block. Staying here. So this is the block. This is empty, nothing is here. So this is the block now we have. So it is given P is acting vertically downward, P, and nothing is others are not given. So P actually will consider only P load. Okay. So P will act downward. The MG also will act downward. Na? We will take P as WMG. Okay. So other force. What will be the other force? Due to friction on force. So first thing first, we have removed the support or surface. Because of that surface, there will be some forces. That is always normal to the surface. Reaction force.
Friction upward.
Friction is upward. That is not friction will act toward the
Body moving down.
that is actually body is sliding like this, na. So this is the plane of surface. So if it is moving this side, the friction will be opposite side. That is okay. But this surface also will give some force, na, that support reaction force. We discussed, na. Hinge support, fixed support. Actually, what we have done earlier. If it is like that.
But this class has that.
Oh no, you are there.
No?
So fixed support. Fixed support, we have some react. If we remove this one, then there will be some reactive force, na. RAD, because of the support. Now we are here. This surface itself is a support. So it will give some reactive force. So we will take this as normal. So this. How many? Actually, I have also given this question. Support reaction, na? 6 inch. No one answered. No, this no. Section A, I gave section A. Okay. So this support, let's say this support will give a reactive force, and we are taking. And always remember that will be perpendicular to the support. Reacting force always will be perpendicular to the surface. So this is the surface. We are taking reacting force that will be perpendicular to the surface. Yeah. So this is your one, and we are taking N1 normal one. Why this force? Because of this surface. Yeah. Any other forces? We are drawing free body diagram. So this is free body diagram of wedge. Let's say this is number 1. Okay. So this is the free body diagram of what? So N1 is reactive force because of surface. There. Any other forces? So this is sliding this side. So our friction will be that side. Clear? Clear? We will say it as F1. Let's say F1 friction 1. Clear? Any other forces you can tell? See, now look at here. We have another block here. So this two block is sliding with each over. So there is also one friction that will be also upward here. So there will be another F2. Clear? So how? Because of sliding, any other forces? See, we have removed this block, So from Newton's third law, what is it? Every reaction. So this block will give some reaction to this block. So that will be like what this side. है ना? That is N2. Done. Actually, this is very important. In wedge friction, drawing of free-body diagram is complex, and you have to remember all these things. है ना? Done. No other forces remaining. Now we have to consider this angle. 75-degree angle is given. Okay. So how many inclined forces are there? Which one? F1 and N1. Now we have to find out the angle of this. So for that we will draw this horizontal. This is our horizontal surface. Okay. So if it is 75 degree, then this is also 75 degree. Yeah. And then what will be this angle? Very good. Yeah. Because this is always perpendicular to the surface. This is 75 degree, then this will be actually in figure it is look like it is bigger, but it is not. We have to go logically, na? So that will be 15 degree. Clear? Yeah. Now we can split into two parts. N1. What is that? Do you have any question? Hello? Your audio is not clear. Hello, who is? Hello? Not clear your audio. Actually, this is 75 degree. How? This is your horizontal line, and this is called corresponding angle. Na? If it is 75 degree, then this will be also 75 degree. Theta and same theta. Just apply this one. Yeah. So this is 15 degree. Now draw its two component here. And the audio is not clear. Huh? You can type also. Message. Chat box you can type. So draw its two line. N1 cos and N1 side. Draw. Speak loudly so that I can also see here. Whatever it is. So this is your N1. Now this will be your N1. Cos. Which one? 15 degree. And this is your. I'm using a different angle. This is your N1 sine 15 degrees. Okay. So this is your actually let it extend in more another way. So let's say this is your F2 na. So this F1 na. F1. So this angle is 75 degree. 75 degree. This angle. So here also we are having 2. Okay. So that is F1 cos 75 degree and F2 sine. Sorry. F1 sine 50. Clear? 75 na? 75. Sine 75. Yeah. So see now how many unknowns are here? All are unknown. We don't know F1, we don't know N1, F2, P we don't know. So we cannot use this free-body diagram. So we will draw another free-body diagram for this block. Draw it. Now you should draw it. Free-body diagram of that block. That is very easy. No inclined force is there. No, on is there. Right. Try this is that is very easy. There are no inclined force. All are vertical or horizontal. This block for this block. Let's say 2. draw three-body diagram of this. Only P, no P is here. This is, and one will be because of Newton's third law. So draw the three-body diagram for that block 2. For online people, if you are having any question, I am not able to hear. You can write it in chat box also. Okay. So draw three-body diagram of that block 2. That is very easy. Three-body diagram of block 2. Draw it. One, good. Now, sir. Sweta, SFC, Sita. 1600, 400, and 1. And others are there. Discuss. Now, sir is not done yet. See, you are doing by your brain, I am seeing by it. That is the difference. We are discussing all this. I have practiced already. Actually. That is the difference. I born earlier. Okay, draw it. Keyword. So block 2, I am drawing here. What block 2? So this is our block 2. Body diagram for block 2. Okay. So see, this is given 1600 is given. It is already given 1600 Newton, and this 400 Newton is also given 400 Newton. Any other? So see, for this block we have taken N2 because of that. So here also this block will also give some reactive force. Now tell me what will be the direction? Yes, na? Yes. Here it is like that, but it is like that. Okay. So same name will be there. N2. 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 So now tell me, any other forces remaining? I just got check. So that will be your, let's say N3. N1 is also given now. Already we have taken N1. So N1, N2, N3. So no other forces are there.
Actually, this surface and that surface.
Same, not same.
Friction changes.
Friction same, but the inclination is other different. Na? So that is the block 2. Any other forces? Friction. So this, what will be that? Upward or downward?
Upward.
See, this block will give F2 upward friction because of that. Then this, for this block, that will be downward. Why? Friction is like that, na? This one is sliding. This block is not moving. This is still resting here. This block is moving. Is it clear? Friction will be downward. So that is, let's say it is downward. And that will be here, na? This side. That is your F2. Now it is complete. Apply summation of F of x is equal to 0, summation of F of y is equal to. Now apply equilibrium condition. Equilibrium condition. That is summation of F of x is equal to 0, summation of F of y is equal to 0. Okay. So if we apply, first we apply for block 2. Block 2. Okay, do it. So that is very easy. And we have all that. Another body is your F is equal to mu r. F is equal to mu r. In this case, our r is what? N. Reactive force. So N1, N2, N3 like that. And this phi is given. What is that? 15 degree. And we will need mu. We know that mu is equal to tan phi. We know this. So tan phi is tan 15 degree. So that is like 0.267. Okay. Now we apply equilibrium condition in block number 2 and solve. Find out the value. Like see another reaction, another friction will be here. What for this surface, na? See for this surface, they are not bent up. That will be your F3 because of this surface. F3. Now see, if you apply summation of f of x, so 400 N2 F3 and others, and be careful for taking sign. Necessary. Understood? So apply summation of f of x is equal to 0 and we are taking positive rightward. Then apply it. So in x direction, how many forces are there? For block 2. See the one? For given phi is equal to 15 degree, you have calculated mu 0.267. Okay. So in x direction, how many forces we have? SSD, tell me any other force. In x direction, for block 2 in x direction. See the figure and tell me. F2 is not in x direction. N2. So N2 is going which direction? Right. So we will take a positive. N2. Any other? N2 is calculated.
N2 is 400
Minus
400.
400. Yes. Any other? F3 we have. F3 is negative. Why F3? Because of this surface. This surface will also give some frictional force, na? So that is F3 is equal to any other force remaining in x direction. So that is equal to 0. Okay. Now we will apply this. So N2 minus 400 minus F is equal to mu N. Mu R, mu N. Reactive force. We have taken as R as N. So mu is 0.2. First we write mu. Mu, that is F3 means N3. Okay. So mu is given 0.267 is equal to 0. So let's say this is your equation number 1. Now similarly apply summation of f of y is equal to 0, positive upward. Same way, calculate. Then find out N2 and N3. You will get another equation in terms of N2 and N3. The same one, similar. How sir, tell me what is that equation? For summation of f of y is equal to 0. So first is our L3 is upward, so let's say L3 minus 1600 minus F3. F2 is equal to 0. So similar way, if you apply N3 minus in 100. F2 means mu N2, mu is 0.267 N2 is equal to 0. Let's say equation number 2. Can you solve it for N2 and N3 from equation number 1 and 2? This is so easy. Solve it and tell me what is N2 and N3. So we will write here. Tell me N2 and N3. Online, are you getting or not? Any question? They're getting all this. What is N2? So it up. No, in terms of value. Priyanka?
Equating them.
Equate, that's all. I know. Still, if you have any doubt, you should ask. Because I am well prepared now. Tomorrow I may not be. Actually, for scoring, engineering mechanics is very easy if you understood. And it's like mathematics, you get full marks.
Yeah, understand, sir. We need the I did not understand. Value 1839.2.
L3 18.2 Newton. And into so this is like two groups, that group and this group. And what are the between the and the stone? So find out N2. From online, find out N2. They are not responding. What is N2? Same way, just you see N3 is already given. For any one equation you put N3 value, you find it. This is correct. No, positive. That will be behind. So it is like competition now. Actually, life is competition. Always. We are also still competing with the faculty. Communication. So N2, what is N2? You put any in any equation now. This is one equation, another equation. You insert the N3 and you will get it.
891.166.
Yes, 890 point something.
891. 891.
91. 91.
1.066.
Okay, that is Newton. So now we have found out N2 and N3. Now we will go this for block 1. The similar way, we apply summation of f of x equal to 0, summation of f of y equal to 0. Or now we will apply for block 1. The similar way, we apply summation of f of x is equal to 0 and summation of f of y is equal to 0. Then you will get another value in terms of A0 and P. That is our objective. So you apply here, all have been splitted in x direction. How many forces? F1 cos 75, N1 cos 15, another N2. That's it. In vertical direction, those forces here. So we apply summation of f of x, summation of f of y, similar way. Okay, apply. Let's say summation of f of x is equal to 0, positive rightward. So problem number 1. Kind of prepare the equation, then find out the solution. Finding is clear. So summation of f of x is equal to 0 will give you which one? F1 cos 75. F1 is positive or negative? Negative.
All in one direction.
That is same. F1 cos 75 degree. Then N2 minus N2. Then any other value? F1, F2 and N1. N1 is which actually N1 is that direction. That is that direction. So that is plus N1 cos 15 is equal to 0. So F1 with mu N1. F1 is mu N1. Apply minus mu मतलब हो गया 0.267 N1 cos of 75 degree minus, let's say this is N1 cos, I am writing here this one, cos of 15 degree minus N2 is equal to 0. So N1 you can take common from this.
N1 I am getting minus 864.
Already calculated.
Minus side only will come.
N2 we have already calculated. N2 is this one.
N2 minus how?
N2 is there. N2 is minus.
N2 is this side.
This side. Na? As a series, clear or not?
Can we get the same?
So N1 is how much?
864.2.
Is it clear? So from here you will get N1. Is N1? What is value? Find out. So N1 is calculated. This is calculated. N2. 891.06. N1 will take common and we will find out. 75 cos 75 cos 15 degree you will start. We will find out solve this. Everything is known except N1 in this equation. Na? N2 is known, cos 75 cos 15 is calculated, constant find out, then find out N1. Let's say this is your equation number 3. No need to put what we are putting. Now the last one, apply summation of f of y is equal to 0. And we are taking positive upward. Now we will be able to solve for p. That is our objective.
And some we are understanding.
First be careful where you are. Anyway, you will get marks for a step. So you apply summation of y is equal to 0. Then what is that? 864.26 Newton. Now we get P. So you apply summation of f of y is equal to 0 and we are taking positive for upward direction value. So this is downward P, F1 sin 75 degree and N1 sin 15 degree. That is also that direction. Okay, this is your direction of the force. Now solve it. Apply the bound equilibrium condition and solve it. Here F2 is also here. Huh? So F2 is here, P is here, F1 sin 75 degrees here, and N1 sin 15 degrees here. So we have 1, 2, 3, 4. 4 vertical direction, 4 forces. So this will be like P is negative minus P. Then your F1 sine positive 75 degree. Then is your F2 is positive upward. And N1 is also positive. N1 sine 15 is equal to 0. Yeah, now everything is known except P. So F1 is calculated how? Mu N1. F2 is mu N2. And N1 is find out. We have calculated already N1. Then you can able to solve for P. Tell me what is P.
244.5.
Huh?
244.5.
240. No. 240. Check.
Equation yeah,
This is the equation. F1 is calculated. Mu N1. N1 is 864. Then F2. F2 is mu N2.
yes.
Huh?
How upwards, sir?
This is upward now. This is your that is your that directional force. Then that component with this direction and that direction. Na? Now you are getting wrong. Any doubt, sir? So let us see one line. Question. Then find out P. Like 10 marks.
676.
Now-
65.
That number. 6.
How to write Delhi?
That is what I am not also
676 point
something like that.
65.
6,
76 point
76 point something.
65.
65 meter. This is your final answer. This is the force after which if you apply 677 then that block will move. This is the maximum threshold condition, limiting condition.
Decimals is in exam, suppose decimals differences.
That is that even a 5, 3, 4 is not also considered. So after 677, after beyond this force, so this block will move downward. Clear? We have time or not? What? Tomorrow we will complete. Tomorrow we will solve another problem.
But actually, one sum is enough to understand the concept.
But we have to at least 2 problems. Huh? Tomorrow I will give question. Today just time is over, na?
Question you can do.
Tomorrow I have to. That is big question. Clear? Any doubt? No doubt. Good, very good. Okay, thank you. I am in front of you, that is why I say